Okay, so let's go ahead and take a look at the odd number questions for this objective. So product rule here. So the second times the derivative of the first plus the first times the derivative of the second. The derivative of 2x squared minus 3 is 4x. So what you notice is that now I'm not telling you to bring down the exponent, reduce the exponent by 1, because we're into product and quotient rule. Okay, so 2x squared minus 3 plus 4x squared plus 8x. So I get 6x squared plus 8x minus 3. Okay, so that's an even question. And then we move along to another odd number question. Now, I will tell you guys that even though this section says to use product and quotient rule, right? Like that's the idea. If it's going to make your life like more difficult, then I don't want you doing it. So like I would have distributed my x squared to both terms. So yes, I can use product rule, but it would make my life super hard. Well, not super hard, but harder. Oh, I'm not doing the derivative yet. I don't know what I'm doing. But I would rewrite this. 2x squared over x squared plus 5x squared over x cubed. So I would get 2 and then plus 5x to the negative first power. So then when I do my derivative of 2 goes away and I'm just left with negative 5x to the negative second power. A lot easier. 4 is an even 1 and 5. So now let's do quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And again, like I wouldn't multiply out the denominator unless I was trying to choose solutions on a multiple choice quiz or test. And that all my answers were that way. So 2x cubed minus 8x minus 2x cubed minus 8x all divided by x squared minus 4, the quantity squared. Don't forget to distribute your negative to both terms. Okay? So f prime of x is negative 16x over x squared minus 4, the quantity squared. That's 6. Here's 7. Let's see. So I want the derivative at that point. I would rewrite this so that I could use power rule. My prime was a little large. Negative 4x to the negative third power. I wanted it x is equal to 1. So y prime of 1. Oops. That's all crooked. Negative 4, 1 to the negative third power. So y prime of 1 is equal to negative 4. That's an even question. Here's another odd number question. Y prime is cotangent of x times the derivative of x squared, which is 2x, plus x squared, times the derivative of cotangent, which is negative cosecant squared. I don't think I would factor anything out, to be honest with you. I would just go y prime is equal to 2x cotangent x minus x squared cosecant squared of x. You don't have to factor anything out again unless it's a multiple choice quiz or test and you're trying to pick the right answer. Okay, so here, even numbered question. Here's another odd number question. Y prime tangent times cosine plus sine times secant squared of x. And I wouldn't do anything with this one either. There's 12, here's 13. So y prime, denominator times the derivative of the numerator, which is secant tangent plus secant times the derivative of x, which is just 1. So y prime is x secant x, tangent x plus secant x. And again, I wouldn't factor out the greatest common factor unless I'm trying to pick out the right solution. All right, so 15. Oops. I guess, you could distribute if you really wanted to, or you could leave it 1 plus cosecant x. Distributing does not eliminate your product rule, so I don't know necessarily if it would be helpful. Let's see, plus cosine times the derivative of cosecant, which is negative, cosecant cotangent. So y prime is negative sine of x. I probably put the negative on the outside. And then minus cosine, cosecant, and cotangent x. And I don't think I would distribute that first set of terms. Okay, so now that is it for this lesson.